Hello, everybody. Welcome back to Chem 140. It is Thursday, week 2. On the bottom of the screen right now, you can see some announcements in the little word bubble that is coming out of my face. These announcements will generally just be updated with what is due soon. So, for instance, the first quiz is due on Monday, October 5th, and the first lab is due Thursday, October 8th. These are always going to be the soft deadlines, unless they're like for exams and the final and stuff like that, in which case it's a hard deadline. Um, Try to get those done by then. If you absolutely can't, the next day I will announce last call, either in class for the lecture on Tuesday or on Friday. I will just send an email and say, hey, I'm going to download all these labs tonight. As long as you have that in there to me by the deadline, I ignore Canvas's flag that says, oh, it's late, deduct half the points. I'm like, whatever. Because I realize that you guys have a lot of stuff going on, trying to make things work during a global pandemic, and also working wherever it is you're working and trying to stay healthy, and also being a student is a lot. So if you miss something by a day, I'm not going to care. Just do what you can. Today's October 1st, which means it is the best month, Orktober, which is why there's an orc at the end of all of our slides cheering us on. Oh, I didn't click the thing here. I gotta do that. It would help if you could actually see the slides. We're going to do Unit 3 today. I keep calling them chapters because we used to call them chapters, but for 140 they're now units. Unit 3 is dimensional analysis. Dimensional analysis is probably the most important skill that you can get from this class. And it's one of those things where everybody thinks they know kind of how to do it intuitively. But a lot of students have not been taught the correct way to do dimensional analysis. So I'm going to preface today's lecture with the caveat that you need to be doing the work by writing everything out by hand the way that I'm going to show you today, because this is the way that you communicate information to people that are going to be in your lives that aren't me, for example. So like future instructors, or maybe you take a position at Boeing and you need to communicate the information to another engineer. The way to do that is to show dimensional analysis. Show your units, show them canceling out. This is how people in the scientific world communicate using math. If you use proportions and start writing stuff like, I don't know, so let's say 1 foot equals 12 inches, so 3.6 feet equals whatever inches. An engineer is going to look at this and go, nope, and you're fired. It is definitely spooky time. I have no idea how to do that with text, by the way. So, don't do proportions like I'm showing you on the screen here. We're going to show a much better way to do that, so we're just going to erase this. Alright. But the first thing we need to do is we need to talk about how we measure things in science. Not like the method, but I mean the how, like what tool or what unit is used, etc. Here's the first convention that we are stuck with, and there is like 1 or 2 countries other than the United States that use what is known as the imperial system. This was probably the best thing the British could have done to screw over America hundreds and hundreds of years ago. And so the imperial system used to be used by the British Empire. And the numbers that were used in the imperial system are stupid. Because they're kind of random, right? Like, who decided that there were 12 inches in a foot? Why not 10? Why not 15? Ugh. Why are there 3 feet in a yard? Who has 3 feet? Why? I only have 2 feet. I don't even want to try with this number. Like, these are stupid. Everything about this is stupid. So, naturally, America uses it. And we use gallons, and we use miles, and we use all these dumb numbers and units that are really, really, really difficult to commit to memory. Because there are just so many of them. Which is why the British Empire and later on the United Kingdom got rid of most of their imperial units, and now they use things like liters. And they do still use some imperial units. Like, people are weighed in, like, stone, which I think a stone is 14 pounds, and that's dumb. So they're not completely off the hook. But at least they've moved to kilometers. As scientists, society has decided that that's silly. We don't want to use all these crazy units. We want something that's easy. And so that's where the metric system comes in. The metric system is completely based on powers of 10. So every unit has some power of 10 relationship to another unit within that subsystem. So, for example, meters. Kilometers and meters are related by a power of 10. Micrometers and millimeters are related by a power of 10. Nanometers and meters are related by a power of 10. And all you do is change the exponent. So you just have to remember what those exponents are, and you're all set. So here are some conversions that involve powers of 10, and you can see that here. So here's my power of 10, and you'll notice that every time my power of 10 is associated with the term meters. And that's because these prefixes that I am underlining have those functional values. It's basically like I'm multiplying, where I'm using the word milli as a number, or the word kilo as a number, or the word centi as a number. Milli is 10 to the minus 3. Kilo is 10 to the positive 3. Centi is 10 to the minus 2. This is way, way easier than memorizing 36 different combinations of lengths to get to a mile. And yeah, we very, very recently defined some distances off of concepts and objects. Like, for a while, we had a kilogram that was a very, very specific platinum, I want to say cylinder, kept in France and stored under argon. And the mass of that thing was the definition of a kilogram. So these units aren't absolute until we define them using physical constants and things that exist. So a lot of this stuff is based off of light, but the subdivisions for these units that we're working with here are all definitions. Now, very important, I am not going to give you imperial to metric conversions, and I'm not going to expect for you to ever commit them to memory, because that's not worth it. Any conversion that you want to look up can be found on Google, and you just type it in the search bar, and you can do whatever conversion you need with that. Now, obviously, on tests and quizzes or stuff, what's going to stop you from taking, like, the number I give you and just throwing it in Google and then converting it and then bring it back? Well, I have my way, is I'm going to put conversions that don't exist on Google. Like, Google cannot tell you how many times a tire spins around if the diameter of the tire is whatever length, and you travel 30 miles on. Like, that's a different type of problem that we will do problems like that. But it is much harder to find answers to those types of questions on Google. So those are the types of questions we'll get. On the screen here, these are all units of length. I don't even know what half of these are. I know what the smoot is. The smoot right here. Where'd my pen go? There it is. The smoot is actually the height of an MIT civil engineering professor, and it's used primarily for bridges. I looked that one up just because I was interested in it. I don't know what clicks are. I think clicks might be something from, like, Star Wars or Gradus. That just sounds like something from the Roman Empire. Hands is used to measure the height of horses. Fathoms is for, like, deep sea travel, and then furlongs is for horse racing. Like, there are all these stupid units. So what we've decided is that, like, these are all dumb. We're just going to use one specific unit and then modify that with prefixes. So the units that we've decided on are called the System International units, or SI units. Clicks are military. Okay. That would have been my next guess. It sounded like something like the Empire would use. So what that means is that for each sort of concept, like length or time or amount, we're going to assign a specific unit to it, and that's going to be the unit that we use in science. What are the types of things that you're going to be using in this class? Now, there's actually 7 of these types of units. We're only going to use 5 of them in Chem 140. In Chem 163, we actually add 1 more of them in there. We talk about the ampere when we talk about electrical current. And then we never use light in terms of candelas or luminous intensity. We don't do that. But those are the other 2 that exist among these 5. So here are the 5 quantities that you're going to be using, and also the dimensional analysis unit that we want. Length is the physical space between one point and another. We're going to measure that in meters. Obviously, meters is kind of a bit big for measuring things to, like, atomic distances or even, like, test tubes, we'll say. So we're going to modify that. The amount of matter something has is going to be measured in grams. That's called mass. Your mass is how much stuff is in you, in terms of like the number of atoms you contain and their effect by gravity. So, or actually that would be weight, I guess. So mass is just the amount of stuff that you have in you. Something to note that the SI unit of the mass is actually the kilogram, but we don't really care about that. We're going to use grams and modify them however we see fit. Time is the interval between any 2 events. We're going to measure time exclusively in seconds, because what else would you measure it in? You can measure it in minutes or hours, but that's essentially seconds for our purposes. Those are just longer seconds. Temperature is how fast an object is moving at the molecular level. We call that thermal energy. Thermal energy is just molecular vibration in translation and rotation. We're going to measure temperature in Kelvin, and the reason that we use Kelvin is a very specific reason that has to do with how we define temperature, and we'll get to that later in the chapter that talks about temperature. And then the last unit, this one might actually be new to you, unless you've taken a chemistry class before. We're going to count quantity of objects, how much of something you have. We're going to measure that in moles. We're not going to really talk about the mole until unit 12, I think? 11, 12? I don't know the new numbering yet. It was chapter 9 in the old textbook. But when we get there, we'll remind you that, oh yeah, we count quantities of things in moles. A mole is basically like, I have X number of things. Just like saying a dozen is, I have Y number of things. So we'll get to that. These 5 things, though, we can all modify using prefixes. So, for example, a meter is too big to measure the length of a piece of paper. Centimeters would be much more appropriate. So I could put centi in front of meters to modify it. If I wanted to measure my mass, grams would be kind of obnoxious because grams are too small. So kilograms would be more appropriate. If I wanted to measure how many moles of water are in the ocean, a mole is just too small of a quantity. So I could do like gigamoles or something like that. So we're going to use prefixes to modify all of these measurements. And these prefixes are shown on the next slide. Now, because this is an online class, you can refer to your notes whenever you want to. It's actually in your interest to memorize these, but you obviously don't have to. Whenever it's time to go back to the classroom, though, and you start taking exams and assessments in class, though, your instructor will expect that you have memorized these prefixes and are able to convert from one to another. So, on the next slide, gotta fix that. Hold on. This might actually kill the presentation here for a second. Boop. There you go. I don't know what you're talking about. Hee. Thank you for pointing that out, though. So please do commit these to memory. Here's the prefixes on the next slide. The ones that we use in chemistry range from tera to pico. 10 to the positive 12 and 10 to the negative 12. And so what you should think of is whenever you see... That's not what I wanted to do. Whenever you see a prefix such as this, you want to associate that with this many of a basic thing. And the basic things are going to be what were on the slide 2 slides ago, the meter, second, Kelvin, gram, and mole. So you can put this prefix in front of any of those things in the following way. So let's go over here. That didn't quite capture something that I could use. So I'm just going to pick these two because they're there. So the way that we use this chart is in the following manner. So if I have a gigameter, what that means is that I have the number associated with it, meters. And we'll put a 1 here, just so it has a number in front. But like any equality, I have an equal sign here, which means that both sides have to be the same value, right? Well, here is 1/2 of the equation, and here's the other. Those two things mean the same value. So whenever you write a relationship using the terms on these charts that I'm showing you here, you got to make sure that you put the number on one side and the prefix on the other, okay? If you do something like this, then you have them both on the same side, and that's not correct, right? That would not be equal, okay? So put the prefix on one side, the value on the other. The other way that I like to commit this to memory is I would always say to my students, and I don't know if anybody really ever listened to this because I would say it over and over and over again, and they would laugh, and then nobody would do it correctly. So, like, imagine that you're going to zen out, and you're going to become one with the universe. Be one with the prefix, and that means put the 1 with the side that has the prefix. Now, what if it's inexact? All of these are exact conversions because they're all counted. All metric to metric conversions are exact. All right, let me get this color back here. So let's write another one for mega over here. So I got a megameter. And yeah, the capital M and the lowercase m do need to be differentiated from each other. So in 1 megameter, how many meters would I have? Well, since mega on the chart is 10 to the 6, Steve, stop messaging me. We would put 10 to the 6 right there. Steve is the other chemistry faculty member that I talk to all the time, so that's who that is. And again, just like before, here's my mega, that equals 10 to the 6. I have one feature on opposite sides of the equality. So therefore it is equal. All right, how do we feel about that? Can we take these numbers from this chart here? I'm going to go back to the lecture slide. Can we take these numbers from this slide and prepare equalities like this? Do you think you could do that? So that's the first step that we need to do. Any questions? Let me know. Meanwhile, I look at a picture that Steve sent me, which is literally him smiling next to a window because he got a window. That's what it's like to be a professor, by the way. You're excited about things like windows. I guess he's doing like home renovation or something. Must be nice to have a home. There we go. Yes, you would be a mega Jeremy if there were a million of you. These slides are a little bit just kind of like, hey, here's what these units are. I don't really think that we need to go through what these are, but I will talk about weight for a second. We're going to talk more about matter and mass in Unit 6, I believe it is. The amount of stuff that is in a person or a bottle or a vial or whatever is considered to be its mass. So the amount of atoms and their independent quantities of protons and neutrons and whatever. We relate those to mass. Now, mass is a feature that is intrinsic to an object. For example, I have a mass. My mass will be constant no matter where in the universe I am, because I will always have the same amount of stuff. But there's another term that is similar to mass, and it is a term that we use here on Earth. It's called weight. Now, a lot of people know their weight in pounds. And a lot of people also know that if you go to the moon... Oops, I thought I had a moon slide on here. I guess I don't. That's okay. A lot of people know that if they go to the moon, their weight changes, because weight is a function of gravity. Weight is your mass times the acceleration of gravity. So weight is a force. But mass is just how much stuff you have. So these are two different things. So be mindful that you aren't misusing the terms mass and weight when you're talking about stuff in the laboratory. The moon slide would definitely be a cheese slice. The last thing I want to mention about weight was that there is a term that we use when you determine something's mass. So when you put something on the balance like this and you get the mass, the term that is used is called weighing. Not neighing. I guess that W could be a little better here. Boop. Now we're A-ing, which is to be a Canadian. There we go. Now we're weighing. So weighing is the act of getting the mass of something in the laboratory, which is really unfortunate. But you're going to hear that term used by other scientists where they say, "Hey, can you go weigh your sample?" And what they intend for you to do is to determine its mass. Okay, so just be mindful that that is terminology that does exist. And I apologize on behalf of chemists everywhere. Volume and area, we're not going to really work with area a ton. Volume we'll work with a little bit. Here, well, let's talk a little bit about what a liter is. A liter is a very specific volume that you really never see out in the real world. You see 2-liter bottles because 2 liters is a pretty convenient amount of liquid to sell to you. But the definition of a liter is a 10-centimeter cube, which you might not have known, which is interesting enough. But this is actually going to become very useful for us, because we're going to use this definition in the following way. So if I have a cubic centimeter for every 1 by 1 by 1 block, I could fit 10 of these in each direction. And the total number of cubic centimeters that would be in this liter would be 1,000. So there are 1,000 cubic centimeters in a liter. Now, if I were to divide both sides by 1,000, I would get that. Because 1 over 1,000 is 10 to the minus 3. Which is the same as this. So, not only do we know how many cubic centimeters are in a liter, we also know how many milliliters are in a centimeter cubed. It turns out that 1 milliliter is 1 cubic centimeter. So that's a definition, and that's where our concepts of volume come from in terms of length. Because you probably noticed that volume was not one of the SI units, and the reason for that is because volume is based off of length. Volume is length in 3 dimensions. So that one, the one that I highlighted there, 1 cubic centimeter equals a milliliter, that's going to be very useful for you to have handy when we do lab work. Because a lot of the time when we work with solids, we measure in cubic centimeters. But when we measure liquids, we use milliliters. And being able to convert back and forth between the two is very useful. Alright, that's the first section. Let me know if you have any questions about that, because now we're going to go into using these units to do dimensional analysis problems. And this is probably what we're going to be doing for the remainder of the day, unless we go through these really, really quickly. Now, in order to do any conversion factor using dimensional analysis, we need those relationships that we established on the previous slide. So let me just put some on the screen here. There we go. So these down here. So we have a bunch of these conversions, and we have even more of them on the table here. And we're going to refer back to those tables as we do these problems. So I went back to the next section, 3.2 here. Here are some sample conversions that we're going to use for a few problems here. And what I need to do to these is I need to make them into something that I can use to convert one quantity to another. Now, the idea that we're going for here would be, hey, if I have something in centimeters, could I turn it into meters? How many centimeters are in a meter? How many meters are in a centimeter? Etc. And the way that that works is by using conversion factors. And the conversion factors are written in such a way that they can then be multiplied, and we'll show that in the next section. So first, let's do this. That didn't cut very well here. Let's see here. All right, so this is our conversion factor. And I'm going to call this the horizontal orientation because it's horizontal. So let's see here. I got to hit Control H. Okay, I can write. So this right here that is up above, we're going to call that the horizontal conversion. And what I want, I can make that a little bigger here. What I want to do is to make a vertical conversion. And what I mean by that would be something like this. So how do I get this information? Well, first, we're going to write the conversion at the top as shown. 1 millimeter equals 10 to the minus 3 meters. Yeah, you could. Conversions are ratios. So that's what we're trying to do, is we're trying to make a ratio. So that's, we'll add that on here. So ratio. So the first step that I'm going to do is I'm going to divide both sides by the same thing. And I'm going to pick 10 to the minus 3 meters. Now, what happens when you divide anything by itself? Like 10 to the minus 3 divided by 10 to the minus 3. What would happen here? Yeah, you get 1, right? Anything divided by itself equals 1. So these numbers divide by themselves, you get 1. Now, if it works for numbers, it also works for units too. You could divide apple by apple and you would still get 1. You could divide orange by orange and get 1. So what that means is anytime you see a unit on the top and on the bottom of a division bar, they divide by each other also. And you get 1. So this whole side right here equals 1. And since this side equals this side, this conversion factor right here has to be equal to 1, and we're going to put that in a box. Except I'm not going to finish writing in the box, and you'll see why in a second. Now I'm going to take the original conversion again. And this time I'm going to divide by the other side. I got 1 divided by 1, that's still 1. And I got something divided by itself, that still equals 1. So what that means is that I have this thing also equals 1. And then here's the fun part, where if I can get it to work here. There we go. Uh-oh. I drew on the wrong layer. That's okay, though. So since I have something that equals 1 and something else that equals 1, they must equal each other. And so what we can do is we can then just get rid of the middleman here. Oops. And go like that. There you go. So this is how we make vertical conversions out of ratio, or that look like ratios, out of these horizontal conversions at the top. That's the mathematical proof that you can do that. You don't need to do that every time, obviously. The gist of it is that for the conversion that's at the top here, I can't actually move the cursor up higher because it's on a different window. But for that horizontal conversion, you can take either of those two sides, make it the top factor, and then stick the other one on the bottom. And that will give you a vertical conversion. We're going to use vertical conversions all the time. And in fact, they are much, much, much more useful than the horizontal conversions. So now I need to do... Oh my goodness, Steve. Let's do... Oh, it's already open, so I'm going to close this. Do you want to save? No. And then I'll make sure I'm on the actual correct layer this time. Cool. All right. So that's a slide that shows what we just did. Now, the important thing about why we did this, in terms of math, is, well, if they equal 1, what happens if I multiply something by 1? What happens to its value? It should remain identical, right? That's the identity property. If you multiply something by 1, you get the same thing out. Now, because these things equal 1, if I were to multiply, say, 6 meters by this, and I chose the correct version of this ratio to multiply by, for example, maybe this one, because I'm going to then multiply by that. If I'm multiplying these two numbers together, this is the same as me doing this. Because this is just the commutative property of multiplication. And now that it's all part of one big fraction, I can do this. Whoop, whoop. And now, when I do the calculation, I have an answer that's in millimeters. So this is the premise behind dimensional analysis. I'm going to pick the conversion factor that helps me cancel out the units I don't want and leaves the units that I do. It is in the interest of a person to find a different unit than the unit that they have. For example, maybe you're driving to Canada and you don't know how many liters of gas you need to buy, but you know that there are like 3.97 liters in a gallon, and your tank in your Jeep is 20 gallons. How many liters of gas should you buy? And then your eyes fall out of your head when you have to pump 80 liters of gas and it's like $1 a gallon or something like that, or $1 a liter. So doing these conversion factors has many, many practical applications. All right. We talked about this earlier. Whenever you're writing your metric to metric conversions, remember that you want to have the number and the prefix on opposite sides of the line. And in other words, you want the 1 to be next to the prefix. So make sure you're doing that. When you are committing these to memory, it becomes difficult to do it for a while, but eventually you will get the practice down with enough of a routine. Now, can you make a conversion factor out of something that isn't metric to metric? And the answer is yes, but you don't have a chart to memorize. In this case, you just look up the conversions and put the numbers where they are supposed to go based on what the conversion tells you. Okay. So, for example, in 1 meter, there are approximately 39.37 inches. And so one such conversion you could do would be to write it this way, or you could flip it upside down. Totally up to you. Whichever one you want. Whichever one will help you solve whatever problem you're working with. Okay. These cannot be constructed from memory because you don't have a handy chart to refer to. So you're just going to have to look them up on Google and get those conversions. Now, a thing to note about sig figs and conversions almost every metric to imperial conversion is inexact. And the reason for this is because one of these is held as the absolute value. In exactly 1 meter, or in exactly 1 gallon, or in exactly 1 pound, and we use that as the benchmark. And then we see where the benchmark falls on the other scale. And the answer is it always falls somewhere between 2 lines. So this top one is exact because it's 1. This bottom one right here is exact also. But the ones with decimals are inexact. So if you're using these conversion factors, the number of significant figures in your answer may be affected by them. Okay? So it's very important to write down as many significant figures as you can for these conversion factors. Now, ultimately, that's going to lead to an interesting problem. And that problem is, well, Wes, if we're going to be looking up our conversion factors online, and then we're going to use those to take the quiz, how do we know that we're using the right number of sig figs for the quiz? And the answer is, I will tell you the number of sig figs to use for conversion problems, and that's how many you'll put in your answer. Or I will instruct you to use at least 4 sig figs in your conversion factor, and then use that to affect your answer. So maybe the number I start you with has 2 sig figs, but the conversion factor is 4. And since you're multiplying, your answer would have 2. In any case, I will not leave it up to chance. There will be some way for you to figure out the correct number of sig figs. Now, I've written this here. Metric imperial conversions are exact, but there is one exception. And that is this. Don't ask me why. Someone said, you know what we're going to do? We're going to align centimeters to inches as a definition. Like, why? Why would you do that? I don't know. It's the one exception. All other metric to imperial conversions that I can think of are inexact. Imperial to imperial conversions are oftentimes inexact too, but most of them are exact. And then finally, metric to metric is always exact. That should be an asterisk there, not a 4. All right. Conveniently, that is all the text that I literally just wrote on the slide. So if you had that slide in front of you or you're reviewing this later, it's the same thing. So. All right. We've already talked about how to cancel out units. When you divide by a unit, the unit goes away. So you can cross out matching pairs if one appears on the top and the bottom. Any units that don't get canceled out, stick around. That'll be important for chapter or unit 4 when we talk about density, because density is 2 units that stick around. Other things have many units that stick around. The whole thing that we're going to be doing is called dimensional analysis, and so hopefully you've picked up that that is what this unit conversion is. All right, so let's do an example. We're going to convert 1.52 meters to inches. If I could click on the right thing, there we go. Well, that's not what I wanted. That's also not what I wanted. Oh my goodness. There we go. Don't mind me while I just move your screen around like that. Okay. I didn't mean to hit that button. All right. So what we're going to do, we're going to convert 1.52 meters to inches. And the first thing that we need to do is we need a conversion between meters and inches. And I've already forgotten the number, so I'm going to quickly go back and look to the slide here. 39.37, okay. So the screen's going to be a little bit garbled for a second here. Where is... There we go. That's what we want. All right, so I have this conversion written horizontally, which means that I could write it vertically like this, or that. Either of those conversions is useful. And now what we're going to do is we're going to take our known value that we're starting with, 1.52 meters, and I need to multiply it by a conversion that eventually turns meters into inches. So my goal is to turn meters into inches. So if that's the case, in this spot that I'm circling right here, that I don't know if you can see, yeah, it's very, very, very barely visible. What unit should go in this circle that I've written here? Oops, I didn't mean to go back 2 steps. So we're going to put meters here. Good. And since our conversion turns meters to inches, we're going to put the inches up here. Once we have canceled out our units, the units that will be left over will be inches. So in other words, we're determining the orientation of the conversion factor by setting up the units. Once we have set up the units, and we get the units out that we want, then you do the numbers. Okay? So do the units first. In fact, we'll write that down. Set up the units first. Then do the numbers. What are the numbers we have? Well, we got to find the conversion that has inches on top and meters on bottom. That's this one right here. So I'm going to put the numbers in as shown. 39.37 inches. And then 1 meter. And there you go. Now you just got to punch that in your calculator and you'll get the right answer every time. Provided that you type it in the calculator correctly. I lost the 7 there. There we go. I got 59.8424. And now, of course, like we've been doing all along, how many significant figures should my answer have? Well, this number right here has 3 sig figs. This one has 4 sig figs. This one is actually This one's actually infinite. Can I undo that? Let's see here. There we go. I have this undo button on my tablet. I should use it. That 1 is infinite because we have to have one part of our equality be exact. Which of those numbers is smaller, 3, 4, or infinite? Well, the answer is 3. So I'm going to keep these 3. There you go. That's how you would measure 1.52 meters and then convert it into inches. Now, the way that I did this, we're going to do more examples. This is the way that I want you to do these problems because this is the way that will guarantee that you do it right. If you do conversions and you don't set up the units first and then do the numbers, if you do it in some other order, you're going to make mistakes. Okay? Getting your mind to do something in an orderly way is very, very difficult. The only way that you can do that is to practice, 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 practice. So I know for a lot of people, you're going to say, oh, I learned it some other way. I'm going to do it that way. And that's where I'm going to stop you and say, no, don't do it. Don't fall back to old ways that are not as effective. Do it this way, because this is the way that everybody wants you to do. And when we start multiplying 5 or 6 of these together, you're going to have a bad time if you do it any other way. All right, so let's get the answer on the screen there. And let's do another one. My poor motorcycle. I have not gotten to ride my motorcycle for an entire year. Because I haven't gone anywhere. That wasn't like to the store. I might have to sell my motorcycle just because now that I have a Jeep and I can actually put my not recyclables. Well, the recyclables too. I had to cart recyclables around. But groceries. I don't know why I said recyclables. I eat garbage, you guys. What am I converting to? So I have kilograms and pounds here. And I need to turn 625 pounds into kilograms. But I'm going to need some sort of relationship here. So we need to go look that up. Where should we go look this information up? Well, let's go find Google. What does Google say? Google says kilograms to pounds. And so you could do that way. You could turn pounds into grams into kilograms. That would take 2 steps. I have this conversion here that says 1 kilogram is equal to 2.2046 pounds. So let's use that. 1 kilogram is 2.2046. So let's do the dimensional analysis. So I need to turn kilograms into... Oops, not kilograms, into pounds. Let me undo. Undo. I need to turn pounds into kilograms, which means that what unit goes on the bottom so that I can cancel it out with this one. We're going to put pounds there. Good. Those will cancel. We'll put kilograms on the top. Since that's our only conversion, that's going to be our units for the answer. Now that we've done that, we do the numbers. 1 kilogram. 1 kilogram. This many pounds. You can write diagonally, however you get the number in there, that's fine. So, how many kilograms is my Harley? It's a Sportster, that's why it's a really light Harley. 283.498. Kilograms. How many sig figs should my answer have? 3 sig figs is right. Because this has 3 sig figs. This is 5 sig figs. This is infinite sig figs. So our answer should have 3 sig figs. Oops, my PowerPoint wasn't actually behind that. There we go. And let's see if we got it right. Hey, look at that. All right. So what we're going to do, when we come back, I'm going to have you do these problems. We're not going to do these just yet. We're going to take a break because it is just about the top of the hour. So we're going to put this on. I got to put the timer on. We're going to put some more Zelda Wave on. Since this is the last day that we're going to have Zelda Wave. Oops, I broke the timer. Hold on. I got to minimize the timer and then fix it. There we go. So we'll start this. And I hope you enjoy this. What is this song called that's coming up? I was sitting here listening to it yesterday, and I just kept hitting replay on it. Astral Observatory. All right, here we go. Oops. I'm sitting here just listening to the music. Like, oh, yeah, I guess I should run the class. So on the screen, I have 3 sample problems for you to try. Actually, I guess there's 5 here. I was only looking at the first thing. So what I want you to do is, on this first problem here, I give you the mass of an orc, and I want you to turn it into grams, and then milligrams, and then pounds. Each of these can be done in one step, provided that you use the answer to the previous one in some cases, okay? There is a conversion from pounds to kilograms. You'll have to look that up on Google. For miles to furlongs, I give you the conversion. This is actually an exact conversion, for what it's worth. I'll even write that down here. For this second problem right here, where I'm putting a little star here, you may need to do more than one conversion. In fact, you may have to do 2 or 3. But what I want you to do is try and do these problems without typing them all into Google. Write out all your work just like I showed you, and then we'll go over the answers in just a little bit. So I'm going to give you about 5 or 6 minutes to do these, and then I'll come back and check on you. I'll still be in the chat, though. Oops, sorry, I hit a key there and I maximized the chat window, and it got all weird. All right, just a few more minutes and we'll go over the answers. All right. A lot of dimensional analysis is obnoxiously inconvenient. And that's okay. Remember that you're learning. So we're going to work through these. So you have another example to look at. My recommendation is if you're having trouble, compare how my work on the screen is to yours. And then try the problems again and rewatch the video later. Let me move this up so I can draw on it. And then keep trying them. So just because you do the problem one time doesn't mean that it's bad. Like it goes bad or you can't use it again. It's not. Problems aren't produce or groceries. They don't expire. So you can always do these problems again. And that's totally okay. That's called learning. So we're going to start with 145 kilograms. And for this first problem, we want to turn kilograms into grams. So if I go and look up a conversion for kilograms to grams, I could find that 1 kilogram is 10 to the third grams. So when I do my setup here, I'm going to put the unit down here that will cancel out with this one up here. So that's kilograms. And we'll turn that into grams using this relationship that we wrote down here. And then finally, we'll put in the numbers. 10 to the third grams. And 1 kilogram. You can do 1,000. I'm just going to... Oops, I got to remove the timer here. In fact, I don't even know why it's on this slide. Boop. Boop. You could write 1,000, but what I do want you to do is use the values that are in the table. And I'll show you what I mean by that when we get to milligrams. So I've got all the numbers in place. I can then do the math, and I get 1.45 times 10 to the 5 grams. And then how many sig figs should I have? Well, this number right here has 3 sig figs. Let's do that in red here. And then these are exact, so they're infinite. So my answer should have 3 sig figs, and it does. All right. For the second problem, I want the mass in milligrams. And what that means is that, well, if I have this in grams, I could then go to milligrams, right? Now, is there a conversion from kilograms to milligrams directly? And it turns out the answer is not one that's easy to use. So my recommendation is that you always go through the base unit, which is right here, the grams. Instead of trying to remember all the relationships between the different prefixes. If you just remember, the conversions to the base unit, using those numbers on the table, then you're committing only the minimum number of things to memory and still will be able to do this proficiently. Okay, so we're going to do it this way. We're going to take our answer with grams and turn it into milligrams. But if I had started with kilograms, I would have to include this first step too. And so I'd go kilograms to grams to milligrams. And so I could just go to the next step. What unit should go on the bottom? Well, I want to cancel this gram out so I can turn it into milligrams. So I'm going to do that. And there's my units. They're all set up, so now we can do the numbers. Now I got to go look up a conversion for grams to milligrams, and this is the conversion that you want to use for milligrams. Now I know a lot of you already know how many milligrams are in a gram. Oops, I can't move this. I forgot. I know a lot of people already know, well, wait a second, can't I just do this? Like, isn't that true? And what I'm going to tell you is don't do that. Don't do this. Don't do this. Because what you're now doing is you are putting the value and the prefix on the same side to do inequality, and you're breaking the pattern of the prefix and the number go on opposite sides. Worst of all, you're breaking that pattern for one specific occurrence. And then when I start giving you things like nanograms, you're going to put the numbers on the wrong spot because you're trying to do everything backwards. Okay? So don't make it harder on yourself. Use the table and how I showed it to you earlier, where you put the prefix and the number on opposite sides of the equal bar. Okay? I know everybody wants to do this with centi, and I know everyone wants to do it with milli, and then you get to micro and nano, and you're like, oh shit, I don't know how to do that because I've never worked with these, and then it all falls apart. So don't make extra rules. Don't make it harder on yourself. Do it the way that I showed you before. So we're going to use this conversion right here. All right, 10 to the minus 3 grams, 1 milligram. And I know that that looks weird to you, but if you get in the habit of doing it this way, it will make your life so much easier trying to do these quickly. And then finally, I do the multiplication. 1.45 times 10 to the 5 times 1 divided by 10 to the minus 3 is 1.45 times 10 to the 8. And my answer still has 3 sig figs because the number I started with also has 3 sig figs. All right, what is the mass of this orc in pounds? Well, I'm going to have to scroll this part down because I ran out of space. So we'll start with 145 kilograms again. And this time I want to turn kilograms into pounds. That means I need to look up a relationship between these two things. And the relationship that I have is 1 kilogram is 2.204 pounds. Again, I want to cancel out kilograms, so I should put kilograms down here on the bottom. I'm going to put pounds on the top. My units cancel out. I'm left with pounds. The units are what I want, so let's do the numbers. Down here I had 1 kilogram, 2.204 pounds. Let's multiply all the numbers together. And that's good. I like when students have those aha moments. I'm going to have to write this diagonally because I'm going to run out of space here. 319.58 pounds. My answer only gets to have 3 sig figs. This is infinite sig figs because it's exact. Or Navi Fairy sig figs. I don't know. My infinite got a little messed up there. You'll notice that I put a big stupid decimal point there because I just happened to round up to a number that I had to put a dot for. Otherwise, you can put it in scientific notation. Either way is fine. All right. How do we feel about those 3 problems? How are we feeling looking at those? Do we feel a little more comfortable doing these now? Do I have more space on my pad here? I do. I gotta do that. All right, let's do 2 more. I commute to work 16.1 miles. I'm just going to do this so I know what to write below. And I want to turn miles into furlongs. And I gave you the conversion here. 1 furlong is 1/8 of a mile. So now that I have my conversion figured out, I'm going to set up the units. I don't want miles on the top, so I'm going to put it on the bottom to cancel it out. I'm going to turn it into furlongs, because that's what I want for solving the problem. And then now I can go in and do the numbers. So 1 furlong, 0.125 miles. And the answer that I got was 128.8 furlongs. Now I gotta do sig figs again. We said that this one was exact. So our answer is only going to be dictated by the initial value. That is a very long horse race. Yeah, furlongs are totally arbitrary. I've only ever been to a horse race once or twice in my life, which is kind of funny because my parents, before I was born, I don't want to say it was professionally raced horses, but they were definitely very heavily involved in that. So I should know what a furlong is. And it wasn't until I was in my 30s and we went to the horse track at Emerald Downs or wherever it is. It's down in Auburn or Kent or something like that. And I looked at the race guide, and it shows all of the lengths of the courses and who's running them. And I was like, oh, furlongs. Yeah, that's where they use these, huh? I talk about those in class all the time. Because you're going to see in the next problem when we talk about the speed of light. That was a day where they had a very interesting race, where I had a 1 in 2 chance of pretty much winning $1,000 on the horse race bet because the outcome was super obvious. But I would have had to spend $60 to do it, so I didn't, of course, because I was poor at the time. And the outcome was just so bizarre, and the odds were just such a long shot that everybody who did bet on it won a lot of money, and I was really sad that I didn't. Anyway, enough about my gambling history. What are we turning this into now? We're going to turn it into centimeters. That's a little bit harder, because we don't really have a conversion for miles to centimeters, do we? So what I'm going to do is I'm going to try and do this stepwise. We're going to try and get somewhere that gets us to centimeters eventually. And this is sort of my segue into the next type of problem, which is where instead of doing one conversion, you do a bunch of conversions. Because remember, each of these conversions equals 1. You can just multiply them all day long. And so that is a valid one that appeared in the chat. We can turn miles into kilometers, and then turn kilometers into meters, and turn meters into centimeters. What's another one that we could do? We could have done miles to feet, to inches, to centimeters. That would work too. All that matters is that wherever you start and wherever you end, you have a path to it. And along the path, you have conversions that are correct. All right, so let's write down these conversions. So in a mile, there are, I don't remember how many kilometers there are in a mile. It's like 1.609. So mile to kilometer. So you can do that, but I want to show you what you would have to do if you didn't have the ability to do that. That's the wrong number. Undo. Undo. It's not undoing. I've lost the ability to undo because Photoshop is weird. Alright, so there's one conversion. I have another conversion here. 1 kilometer, 10 to the 3 meters. And then 1 centimeter, 10 to the minus 2 meters. So we're going to have to use those 3 conversions to solve this problem. So let's do that. So for my first step, I'm going to turn miles into kilometers like I have blueprinted down here. Then for the second step, we're going to turn kilometers into meters like we blueprinted down there. So we'll turn kilometers into meters. And then the last step, we'll turn meters into centimeters here. So meters, centimeters. Am I capturing that on screen? I am. Okay, cool. Centimeters is the only unit left, which means that my answer will be in centimeters once I run the numbers. So let's run the numbers. Let's fill them all in. 1 mile was 1.609 kilometers. 1 kilometer was 10 to the 3 meters, and 1 centimeter was 10 to the minus 2 meters. We'll punch all those numbers in the calculator, and it makes a happy face. And I got 2.590490 times 10 to the 6 centimeters. Now I got to do sig figs. And this is where knowing what's exact and what's inexact is going to help us, because we know that these are metric. So this is exact, and this is exact. So I don't got to worry about those. If there's a 1 by itself, it's exact, but the rest of these are going to be measured, because this is imperial to metric. So this is 4 sig figs, and this is 3 sig figs. Which of those is the least? 3 sig figs, so I'm going to keep these, and I got to keep this part too. And there you go. That should be the answer to this problem. Now, if you looked up how many centimeters are in a furlong, again, that'll work for these problems. And I'm certainly not going to stop you from doing that. But in class, I might not give you those conversions. I might only give you select conversions. I put in the wrong number. 1, 2, 3, 4, 5. I should look at the calculator, not what I wrote. 3, 4, 5. I got 6. $16.1, 1.609, 10 to the 3, 10 to the minus 2. Yeah. I still got 10 to the minus, or 10 to the plus 6. If you got 10 to the minus 5, that might be an issue with how you typed it in the calculator. Make sure that you're using the E button, like the small capital E, or an EE. It depends on what calculator you're using. If you're concerned that you're typing it in wrong and you're getting the wrong answer, take a picture of your calculator and send it to me, and I'll tell you what to use, because I've seen virtually every calculator out there, and I can show you how to do it. Oh, I see what you're saying. Okay, so this right here and this right here, that would give you a number that is times 10 to the 5. But these two numbers multiplied together give you a number that would be this. And so when I move the decimal point over, that happens. There you go. Sorry, but that's also another thing that does come up. So if you're typing stuff in your calculator and you're getting the number right, but the exponent is off by 1 in either direction, take a picture of your calculator and send it to me. And I'll be happy to diagnose that, because that's really common, and not all calculators operate the same way. All right, any other questions on these before we move on to the last set of problems that we're going to do today, which is more of this. Let me know in the chat. Oops, that's not the PowerPoint. There we go. All right, so now what we're going to do is we're going to try to take that idea of having multiple conversions and doing them for other types of problems. So for example, let's suppose that we have this problem. So you might know the velocity of something and have to convert it to units. For example, maybe you're speeding down the highway and you wanted to know how many meters per second you were going, or something like that. Here is the velocity of a bullet. What would the speed of this be in miles per hour if you could literally go as fast as a speeding bullet? Would that actually be very impressive? We'll find out. So, I had to resize the window here. So let's look at an example and see what we do. And I hope everybody has written everything that they want, because, oh, it's gone. And that's okay. You can always rewind the video. In fact, I think you can even rewind the video right now. Just something to note. Some people write seconds as just S. Some people write SEC. I do SEC just to be clear, but either one is fine. I think the SI unit is just the letter S, but my handwriting on a tablet on the internet is such that it could look like a 5 or something like that. So I'm going to write SEC for seconds. Now, in this case, I have multiple units that I need to convert. I don't want meters per second. I need to get to miles per hour. In order to do that, what I'm going to have to do is I'm going to have to convert each of these so that they become these. And so the way that we're going to do that is we'll just do one at a time. Turning seconds into hours is very easy. There, we're done, right? How many seconds are in a minute? That's easy enough. We know that one. And then how many minutes are in an hour? 60 minutes is an hour. And now we'll do the same thing on the top here. How do I get from meters to miles? Well, I'm going to just arbitrarily pick meters to kilometers. And then choose kilometers to miles. Because I know that a kilometer is 1,000 meters. Yeah, isn't Google great? Because that's something that you needed to know, right? Is how many Planck lengths there are in a furlong. How many kilometers are there in a mile? I think it was this. Now we have all the relationships written down and all the conversions for our units. We just have to follow the arrows. Don't abuse Planck's constant. You will collapse the universe. And that would be bad. Actually, I guess it can't really be much worse than 2020. So, you know, you do you. All right, so now that we're going to cancel these units out, again, remember, put the units in first. Let's just start by getting rid of what was on the top, like we know. Following our chart, we're going to go from meters to kilometers. And if you get stuck, remember, write out these charts. The charts might help you. If it helps you organize your thoughts, then excellent. The whole point is that you get to the answer by whatever means works for you. Okay. So I'm going to follow my chart. Kilometers goes to miles. And if I were to hit enter and just stop here, I would have an answer in miles per second. But I don't want miles per second. I want miles per hour. So I need to keep going. And I need to put another conversion down. This guy right here, I want to be in the final answer that I report. So I'm just not going to convert that anymore. That one's done. Now I need to deal with seconds. But how the heck do I cancel out seconds? It's on the bottom. If I do this, it doesn't work. Because they don't cancel. So, well, if I can't put it on the bottom, oops. I accidentally clicked on the chat and it closed the window. Or it closed my PowerPoint here. Whatever this is I'm working in. Where do I put the seconds? If I can't put it on the bottom... I'll put it... Where? Should I put it over here? No, that's not going to work. Yeah, you just put it on the top. Excellent. Because now it cancels out like that. And it doesn't matter that they're not next to each other. You can multiply or divide in any order you want to, right? 2 times 3 times 4 is the same as 4 times 2 times 3. So just because they're apart doesn't mean they don't still cancel. And then we'll turn seconds into minutes, because again, we're following our chart down here. And we'll turn minutes into hours in the same way. Minutes, hours. And now that we've done that, we have the units that we want for our answer. And so once we run the numbers, we'll get the correct answer. So now we'll go back and use all of our conversions. So here's kilometers to meters. 1 kilometer, 10 to the 3 meters. So we got that one. That one's done. I've got kilometers to miles here. And again, you want to make sure you put these in the right spots. Make sure you put the numbers in the correct spaces. Minutes to seconds, that's this down here. There are 60 seconds in a minute. Be very careful that you don't accidentally put the 60 on the bottom, or else class would have been done ages ago. And then finally, there are 60 minutes in an hour. That's this one right here. And you're all set. Punch it in the calculator. Not like I did. I hit an extra key and it messed up everything. And when you do this, I got that for my answer, which is actually pretty impressive. So, if Superman is faster than the speeding bullet, he's doing pretty good. And of course, the last thing we got to do is sig figs. So that's metric to metric. These are counted. This is 4. And this is 2. So our answer should have 2 sig figs. So we'd round this to 100 or 1,700 miles per hour. There you go. So that's how we do a conversion with multiple steps and a top unit and a bottom unit to both consider. So in the next problem that involves the speed of light, you're going to have to do that. And we have time to do it, so I'm going to have you try that. Oops, I didn't actually click on PowerPoint here. And yeah, that is about Mach 2. Speed of sound is what, like 700 miles an hour, something like that? It's really darn fast. Alright, So here you go. Here's the speed of light. The speed of light is 3 times 10 to the 8 meters per second. This is not an exact number. It looks like it is, but it turns out light just happens to go almost 3 times 10 to the 8 meters a second. I want you to turn this speed into miles per hour. And then my favorite unit, furlongs per fortnight. A fortnight is 14 days. So I'm going to give you about 6 or so minutes to do this. I'll come back at 3:55. I'll still be in the chat, of course. I'll just be silently browsing Twitter on my phone or something. I don't know. Go ahead and get started on these problems. We'll go over the answers, and then we'll call it a day. See you in a bit. All right. Let me hit this. Make that a little smaller just so I have more space to work with here. Boop, boop. All right, so I got the speed of light. That's the wrong color. I'm going to write the units out like that. So that I can then cancel out my units in an easier way. So meters per second. We're going to turn that into miles per hour. We're going to do exactly the same thing that we did before. So seconds go to minutes and minutes go to hours. Meters go to kilometers and kilometers go to miles. And because we're running out of time, I'm just going to write down, we're going to put all the unit conversion in, and then I'll go look up the numbers really quickly. So meters to kilometers, just so you have the answer on this video. So there's my miles to seconds. I got to get seconds into minutes to cancel that. That's wrong. Minutes into hours. And then we can fill in all the numbers here. So 60 seconds in a minute, 60 minutes in an hour, 1.609 kilometers in a mile, and 1,000 meters per kilometer. All right, and I put my phone on my calculator. That's a bad spot for it. 3 times 10 to the 8. I'm going to make it do scientific notation for that for me. Answer. And I got this. 6.712 times 10 to the 8. I'm not going to keep all of those sig figs. This is in miles per hour. Same as before. That's going to be 3. This is going to be 4. These are exact. So my answer should have 3 because of that. All right, so there it is in miles per hour. We're going to use that number in just a second so that we can go to furlongs per fortnight. You could do furlongs per fortnight from the starting point. We'll do this one in pink here, so because this is an easy conversion. And that's a pretty easy conversion, too. That decimal's a little bit hard to see. So that's... Oops, that's not year, sorry. Can't read my own handwriting up there. There we go, miles per hour. And then we'll do miles per furlong. Furlongs is what we want. We want fortnights, so I'm going to turn hours into days. And then days into fortnights. There you go. Those are the units that we want, so those will be the units of our answer. I don't know what the abbreviation is for fortnight. All I know is it's a game that everybody plays. So there is 0.125 miles per furlong, 24 hours per day, and 14 days per fortnight. And I get 1.80 times 10 to the 12 furlongs per fortnight. There you go. 3 sig figs because the numbers we used had 3. The other ones were exact. All right, so that has been a primer on how to do conversion factors and dimensional analysis for one-dimensional units in both positions, the top and the bottom. So what we're going to do when we come back on Tuesday next week is we're going to finish Chapter 3 where we start using other dimensional units so we can turn like cubic inches into cubic centimeters and stuff like that. But what I do want you to do over the weekend is do as many practice problems as you can from the text, from the worksheet. Don't do any of the cubic problems yet. Don't do anything that involves like inches to cubic centimeters or whatever. We're going to do that on Tuesday, and we'll finish Unit 3 then. Then Thursday next week will be Units 4 and 5. Keep in mind that the quiz number 2 will be only Unit 3. So I anticipate that when we finish Unit 3 on Tuesday, I will release that quiz for you to take. Do mind the deadlines at the bottom of the screen, because those will come up faster than you would expect. The weekends go pretty quick, and as of this point, we are actually already 20% finished with this class, so blink and you'll miss it. I want to thank everybody for showing up today. Thanks for coming out to the lecture on Thursdays. Let me know if you have any questions about the first 3 units that we've covered so far in either email or on Canvas. Use the discussion board. Make sure you're using that Discord that other people were posting around. Have a wonderful weekend, and I will see you next week.